Hello students, to chemistry, chapter is chemical energetics, lecture number 3. In this lecture, we are going to study how to write down thermochemical equations for the formation of ionic compounds using Hess's law. The type example to start with, we will take the example of NaCl, sodium chloride. If you have not subscribed this channel yet, I invite you people to subscribe this channel and also push the bell icon. Thank you. Okay, to start this lecture, first of all, let me give you an idea, a quick revision about what is Hess's law. Because based on Hess's law, we are going to write down equations for the formation of sodium chloride, that is an ionic compound. Now, what you must remember for the Hess's law, there are two pieces of information that are most important that we must remember about Hess's law. Number one, you must always remember, according to Hess's law, whenever a chemical reaction, a chemical process takes place, every chemical process can be completed through two different paths. One path by which a chemical process can take place, it is known as direct path. And the other path by which a chemical process it can take place, it is known as indirect path. So this is the basic information that we must remember about Hess's law, that a reaction can take place through direct path or through indirect path. Now what is the difference? Very simple. Direct path, that involves one step only. Whenever a reaction is completed using one step only, it is known as direct path. And whenever a reaction takes more than one steps, it may take two steps or three steps, that is known as indirect path. This is one information that we must remember about Hess's law. Second information that is even more important about the Hess's law, it is whenever a reaction takes place, whenever a process takes place, whether it has taken through direct path or it has been completed through indirect path, the total enthalpy change, it remains same. It means enthalpy change of the direct path, it is always equal to enthalpy change of the indirect path. So these are the two pieces of information. Just to have a quick revision in your mind, you can remember about Hess's law. Now let's write down thermochemical equation for the formation of sodium chloride, that is an ionic compound. But before that, remember, we can write down thermochemical equations through two different paths, direct path and indirect path. What you should remember before writing thermochemical equations, whenever we write down thermochemical equations for an ionic compound, indirect path, it always involves three steps. There are three steps for the formation of an ionic compound through indirect path. What are those three steps? Number one, atomization. Number two, ionization. And number three, formation of ionic lattice. I repeat, atomization, ionization, and formation of ionic lattice. Let's write down thermochemical equation for the formation of sodium chloride. Now, first of all, whenever you are given a compound and you have been asked to write down thermochemical equation, what you must do, you should write down equation for the direct path. What does this mean? It means you must prepare that compound in one step. Now, how you can prepare sodium chloride in one step? It is very simple. Just look at the formula of sodium chloride and identify which elements we must mix to produce sodium chloride. So you can easily understand that sodium chloride is a combination of two elements. Number one, sodium, Na, and number two, chlorine, Cl2 gas. So these two elements, when they combine and if they produce sodium chloride in one step, that one step can be known as direct path. Now, to balance this equation, since we are interested to prepare 1 mole of sodium chloride, what we can do, we can balance equation accordingly. On the left hand side, before chlorine, we can place 1 by 2, 0.5 mole of chlorine gas. Now this is a balanced chemical equation. It represents direct path because it involves one step, and still it is a balanced chemical equation. Now how you can change it into thermochemical equation? That is very simple. To make it a thermochemical equation, simply you will have to label the enthalpy change of this chemical reaction. What is the enthalpy change of this chemical reaction? It is standard enthalpy change of formation. Now this balanced equation, now it is known as thermochemical equations. Thermochemical equation, because we have labeled the enthalpy change involved in this step. Now this is the direct path. Let's start writing thermochemical equations through indirect path. And I told you, in the indirect path, for the formation of an ionic compound, three steps are involved. Step number one, atomization. We will atomize these two elements first of all. So what is atomization? Simply, you should remember, you must write down the symbol of an element, and at the base of that symbol, the state symbol should be gas. This is atomization. Whenever you want to atomize an element, you must use the symbol, you must write down the symbol of that element followed by its state symbol. State symbol should be gas. Now what label, which enthalpy change this reaction involves? This is enthalpy change of atomization, and this is enthalpy change of atomization of sodium multiplied by 1. Why multiplied by 1? Because we have produced 1 mole of sodium. So make it a habit, student, whenever you are going to write down these enthalpy changes, you must remember that there is some number that must be multiplied with these enthalpy changes. Why? What is that number? That number is the number of mole present in the balanced chemical equation. Likewise, after sodium, let's atomize chlorine. How to atomize chlorine? Write down the symbol of chlorine, state symbol gas. Now chlorine has been atomized. There is 1 mole of chlorine. So the label of this reaction arrow will also be standard enthalpy change of atomization multiplied by 1. Now both the elements which are present in sodium chloride, they have been atomized. Now atomization step is completed. Now what next? We will carry out ionization of these two elements. Now there can be two different types of ionization. For metals, ionization is the oxidation, is the loss of electron. For non-metals, ionization is reduction, it is the gain of electron. Sodium, you people know very well, it belongs to group number 1. So sodium will lose 1 electron and it would get a charge of 1 positive. This is ionization of sodium through oxidation, and enthalpy change for oxidation is known as ionization energy. So what label you will introduce on the reaction arrow? You can write down first electron affinity of sodium multiplied by 1. Why this is first ionization energy? Because sodium has lost 1 electron only, and it has also been multiplied by 1 because there is 1 mole of sodium. Now the electron lost, we where that electron has gone which has been lost by sodium, that electron will be gained by chlorine. Chlorine belongs to group number 7. It needs 1 electron to complete its valence shell. So chlorine will gain 1 electron. It would get a charge of 1 minus gas. Now what this enthalpy change that is linked, that is related to reduction or gain of electron, it is known as electron affinity. So what you can label for the reduction of chlorine, for the ionization of chlorine, you can write down first electron affinity multiplied by 1 because there is 1 mole of chlorine. Now we have completed the second step for the indirect path of the Hess's law. First step is the atomization followed by ionization. Now ions are ready to react. These are oppositely charged ions. They will attract each other, resulting in the formation of an ionic lattice, sodium chloride. And whenever an ionic lattice is formed, the enthalpy change for that step, it is known as lattice enthalpy. You can see thermochemical equations have been completed for the formation of sodium chloride, and we have written equations using direct path as well as using indirect path. So what is the most important information that you must remember? that indirect path for the formation of an ionic compound, it involves three steps, namely atomization, ionization, and formation of lattice. Okay, students, on the next slide, I'm going to give you an example of a slight difficult compound, that is thermochemical equations for the formation of aluminum oxide. Now, this can be the most difficult question that can be asked in your A2 syllabus. So try to understand all the important informations, how they can be written while presenting thermochemical equations using Hess's law, using direct path and indirect path. Let's start for aluminum oxide. Now, first of all, as I told you, whenever you are asked to write down thermochemical equations, first of all, you must write down direct path. You must identify which elements we should combine to produce aluminum oxide. Aluminum oxide can be produced by mixing aluminum metal and oxygen, diatomic gas, non-metal. To balance the equation, you must keep 1 mole of aluminum oxide on the right hand side. So we need 2 mole of aluminum and 1.5 or 3.5, 3 by 2 or 1.5 mole of oxygen on the left hand side. Now you can see your equation is balanced. 2 mole of aluminum on both sides, 3 mole of oxygen atoms on both sides. Now this is a balanced equation. To change it into a thermochemical equations, you will label it. This is standard enthalpy change of formation. Okay, the direct path has been completed. As I told you, in the indirect path, there are three steps: atomization, ionization, and formation of ionic lattice. Atomization, it is simple in this case, no problem. Simply atomize aluminum, symbol of aluminum, and the state symbol gas. But now we are having 2 mole of aluminum. We will multiply it by 2, and also while labeling the enthalpy change, you are supposed to write down standard enthalpy change of atomization multiplied by 2. This is atomization of aluminum. Now to atomize oxygen, write down the symbol of oxygen, its symbol gas, and there are 3 oxygen atoms. So we will multiply this oxygen by 3. And what enthalpy change you will label on this reaction arrow for oxygen? It is atomization of oxygen multiplied by 3, because there are 3 mole of oxygen. Moving on, now you have atomized both the elements involved in the formation of aluminum oxide. Moving on, you will write down equation for the ionization of these elements. Now here, students, you must be very careful in labeling ionization of aluminum and oxygen. Why? Look at this. Aluminum, it belongs to group number 3. So what does this mean? One aluminum can lose how many electrons? One aluminum can lose 3 electrons. So when one aluminum will lose 3 electron, it will get a charge of 3 plus. Now one aluminum has lost 3 electron. What this enthalpy change will be known as? This enthalpy change will be first ionization energy plus second ionization energy plus third ionization energy. Why? Because same atom, it has lost 3 electrons. So that is why you must remember, in this case the enthalpy change is first plus second plus third ionization energy. But before that, you should also balance the aluminum on both sides. There are 2 mole of aluminum. Forget about 2 for the time being. Simply remember, enthalpy change is first plus second plus third ionization energy. And then you can see we have also multiplied these ionization energies by 2. 2 indicates that there are 2 mole of aluminum. Now aluminum has been ionized. Aluminum has lost 6 electron. One aluminum atom has lost 3 electron. two aluminum atoms, they have lost 6 electron. We are having 6 electron, and we are going to ionize oxygen. What you know, one oxygen belongs to group number 6. One oxygen, it is in need of 2 electrons. But right now, how many oxygen atoms are available with us? There are 3 oxygen atoms. So one oxygen, if it will gain 2 electrons, 3 oxygen will gain 6 electron. So you can see the number of electrons lost by aluminum is equal to the number of electrons gained by oxygen. So what you will write down, oxygen by gaining 2 electron, it will become O2 minus, and there are 3 mole of oxygen multiplied by 3. We also know whenever electrons are gained, enthalpy change is known as electron affinity. But oxygen has gained 2 electron. So for each electron gained, there is electron affinity. So what is the label for this arrow? First electron affinity plus second electron affinity multiplied by 3, because there are 3 mole of oxygen atom. So this was the difficult portion of this thermochemical equations for aluminum oxide. I hope you would have understood this. Next, the last step, it is very simple. Simply ions, they combine together and result in the formation of aluminum oxide lattice. And this enthalpy change is known as lattice enthalpy. So students, simply look at while labeling ionization enthalpies, you must be careful that which ionization enthalpies and how many ionization enthalpies are involved. Rest, it is very simple. Okay, this is the most difficult example that can be asked in your A levels exams. And after sketching, after writing these thermochemical equations, now you have also become able to apply Hess's law. Let's apply Hess's law. Now, how to apply Hess's law and write down a formula for doing calculations? What you must remember, whenever you want to apply Hess's law, you must be able to identify initial stage and final stage. It is very simple to identify initial and final stage. Identify that position of the elements where two arrows are having their tails. Two arrows where they are taking a start, that will be the initial stage. And what is the final stage? Where both the arrows, they end up, they are having their heads. So have you got what is the initial stage and what is the final stage? Okay, I am labeling. Try to understand. This is the initial stage. Why? You can see there are two reaction arrows. One arrow is moving in the toward the right side. Other arrow is coming downwards. But both the arrows, they are touching their tails with this position. So that is why this position is the initial stage. Now, if you have understood this initial stage, you have identified the initial stage. Now try to identify the final stage where the two arrows, they are touching their heads. Yes, it is aluminum oxide solid. This is the final stage because both the arrows, they are having their heads. Now you have identified initial and final stage. You will identify the direct path from initial to the final stage. Remember, a direct path involves one step only. Right now, which step is the direct path? It is the standard enthalpy change of formation. So this is the direct path. So students, I can give you a simple tip, that you can remember. Whenever there is an ionic compound, its direct path will always be standard enthalpy change of formation, always. For the formation of an ionic compound, direct path is always equal to standard enthalpy change of formation. So if we apply the Hess's law, enthalpy change of the direct path is equal to sum of enthalpy changes of indirect path. So what is the direct path in this case? Direct path is standard enthalpy change of formation of aluminum oxide. It is equal to atomization of aluminum into 2 plus atomization of oxygen into 3 plus first plus second plus third ionization energy of aluminum multiplied by 2 plus first plus second electron affinity of oxygen multiplied by 3 plus lattice enthalpy. So you can see that whenever we will apply the Hess's law, we must be able to identify initial and final state. After that, it becomes very easy to apply the Hess's law. Now this formula is very helpful. Once you have written this formula, numerical values for all these enthalpy changes except one enthalpy change will be available to you. So you can find the numerical value for the unknown enthalpy change. So this is the purpose of this formula, to do calculations for Hess's law and Born-Haber cycle. Okay, students, I hope you would have understood how to write down thermochemical equations for the formation of an ionic compound. Let's practice 2-3 examples in this video. You can pause the video. I'm going to give you compound. You can pause the video. You can sketch this cycle. You can write down these thermochemical equations and also apply the Hess's law to write down the formula. Then I will show you the answer. You can check it. Okay, write down equations for the formation of sodium sulfide, Na2S. Okay, students, if you have written thermochemical equation, you can check it yourself. First of all, direct path for the formation of sodium sulfide, indirect path atomization of both these elements, followed by ionization, followed by formation of lattice. One thing, students, some of you might have written S8 sulfur. Sulfur exists as S8. That is correct. That is not a problem. But if someone has written S8, there must be 1 by 8 S8. 1 by 8 S8. But if you have written S, even it is acceptable. It is not a problem. Okay, if you have applied the Hess's law, what formula you must have got? I have told you that whenever there is formation of ionic compound, direct path, it is always the enthalpy change of formation. This is the initial stage. This is the final stage. Always remember enthalpy change of formation during the ionic compound formation. Enthalpy change of formation is the direct path. It is equal to atomization of metal plus atomization of non-metal plus ionization energy of metal, electron affinity of non-metal plus lattice enthalpy. Okay, have you done it correctly? I hope so. Let's do the second example. If you have done some mistakes, you can make some improvements in the next case. Okay, write down thermochemical equations for the formation of calcium fluoride. Okay, students, if you have written, just check it out. Try to identify any mistakes if you are making. Try to make them correct and do not repeat them. Again, this is initial stage, final stage, and enthalpy change of formation is the direct path is equal to atomization of metal, atomization of non-metal. First plus second ionization energy of calcium plus first electron affinity of fluorine plus lattice enthalpy of calcium fluoride. Correct? Okay. One last example. Just give it a try and try to solve it correctly. It is for the formation of magnesium nitride, Mg3 and 2. Okay, students, if you have written the equation, just check it out. Formation, that is the direct path, atomization, ionization, lattice enthalpy, initial, final stage, delta HF. Direct path is equal to atomization of metal, atomization of non-metal plus ionization energy of metal plus electron affinity of non-metal plus lattice enthalpy. So students, I hope you have understood this lecture properly. If you have any problem, just you can watch it again and try to improve your concept. Thank you for your time. Bye for now.